to fix the limits, we have to use again a loop. This loop will recalculate the maximum and the minimum values for each of the velocities. Then we will extract the minimum of the minimum and the maximum of the maximum. So how do we do this? Let's uncomment it first. Create our vector for I length 1 to the length of x v, and down here we have to end. Move it a bit further. All right, now our x max, y max, and the other values that we have here are now going to also become vectors, because every different condition that we have will generate different values. The different values will have different minimum and maximum values. The different vectors will have different minimum and maximum values. So we need to find all of the minimum values, all of the maximum values, and we are going to vectorize these things. So we're going to vectorize them, and we're going to take the current corresponding y velocity that we are calculating. We are going to take, what else do we need to take? Here we need to do the same thing for all of the velocities actually. So let's do this, and all right. Now we have to also take the corresponding time value. The way to do this is we are going to take the first value of the current row. So current row, first value, current row, first value. Here we need to take current row, last value. Here we need current row, middle value. Same thing here. And here, current row, first value. So here we will generate all of the minimum and maximum values that we will have for all of our different conditions. Then we have to find their minimums and maximums. So let's run it. It's probably going to spit an error. Yes, it does. Where does it do it? And we also need to use the currently calculated ymax value here, because we otherwise we're trying to calculate a value and then subtract a vector from it. So that is why first I calculated the maximum values and not the minimum values. Do the same thing down here. Finally, we have to find the final minimum and the final maximum value. So I'm going to generate x limits vector, which will be the minimum of x min and the maximum of x max. If you try this, now you can see that x min is a vector. So we need to find the absolute minimum of that x min vector. So min of x min will give us a single value. We do the same thing for the y limits, min of y min, max of y max, and we will use these down here. Now we should generate the correct limits. There we have it. As you can see now, our limits are correct and are according to our biggest plot. Now you could say, well, why don't you just pick the highest velocity and calculate it for that? Why do you do this? Well, because the velocities may not be ordered as they currently are. I thought you could probably still try to find the maximum velocity and work with that, but yeah, let's practice loops. So here the final problems that we have is it's complaining that these are changing the size on every iteration, so it wants to pre-allocate them. So let's do it very quickly. X max will be of zeros of size of the xv, and this will be y min, this is x min, and this is y min. There we have it. Now one last sprinkle that I want to add to our plot is I want to add two black lines. I want to add one black line here and one here, purely for cosmetics. The way to do this is to simply use our limits and generate them. So black line for y equals 0 and black line for x equals 0. Here we will use plot, and we will plot between both x limits. So x limits, and we will keep that line at the zeros, 0 and 0. We're going to make it black, and we're going to make it a bit bolder. So line width of 2. The same thing will happen down here, but instead of using the x limits, we are going to use the y limits. Y limits. Let's try again. There we have it. Now our plot is completed and it looks a bit better.